Hello everyone. In this video, we are going to discuss about law of conservation of energy. See, energy exists in different forms. Examples are light energy, nuclear energy, heat energy, potential energy, kinetic energy, etc. Energy can be changed from one form to another form. According to this law of conservation of energy, energy can be converted from one form to another. It can neither be created nor be destroyed. We cannot create a new form of energy to the already existing total energy in the universe, and we cannot destroy a form of energy, but we can convert a form of energy into another form of energy. For example, we can convert electrical energy into light energy. Okay, we can convert electrical energy into heat energy, like that. So we can convert one form of energy into another form of energy. Energy can neither be created nor be destroyed. So the total energy before the conversion and after the conversion remains a constant or remains the same. Let us consider an example. Let an object of mass m be initially here, which is at a height h from the ground. Initially it is at rest. Okay, so what about its velocity? Its velocity is equal to 0 now, because initially this object is at rest. So its velocity is 0 here because it is at rest. Okay, see what kind of energy is possessed by this object? Potential energy, no? Because it is at a height h above the ground. So this object possesses, the object possesses some potential energy. Right. So what about its potential energy? We have the expression for the potential energy. Potential energy EP is equal to mgh. Right. We have already discussed about this expression in our previous video. I hope you remember that. The potential energy possessed by an object of mass m when it is at a height h above the ground is EP is equal to mgh. What about its kinetic energy here? Kinetic energy Ek is equal to 0 now, because the object is at rest. Okay, we have the general expression for kinetic energy as half m v square, where v is the speed of that object. Alright, so here the object is at rest. In this position 1, the object is at rest, so its velocity is 0. 0 into any value will give you 0. So its kinetic energy is 0 here. Okay, so the total mechanical energy of the object when it is here in position 1 is what? I am taking the total mechanical energy as E, which is equal to kinetic energy plus potential energy. What is its kinetic energy here? 0. Potential energy mgh. So kinetic energy plus potential energy means 0 plus mgh. 0 plus mgh will give you what? Mgh. Okay, now when this object falls, okay, you just imagine it is falling down. So when this object falls freely from this height, it will be falling down with some velocity, no? Okay, that is the object will have some kinetic energy. Okay, if an object of mass m has some velocity v, then it will have some kinetic energy. Okay, so when it is falling down, what happens to its potential energy? See, when it is falling down, its height from the ground decreases, no? So potential energy decreases. H decreases, so potential energy decreases. Okay, so initially its potential energy was maximum and kinetic energy was 0. When it is falling down, its potential energy decreases and kinetic energy increases. Because when it is falling down and when we consider a particular point here, it will have some velocity because it is falling down. So it has some velocity. So it has some kinetic energy here. And it is still above some height above the ground. So it has some potential energy too. Okay, so when the object is falling down, its potential energy decreases and kinetic energy increases. That is, sum of its potential energy will change into its kinetic energy. Now, when the object reaches here, that is when the object is about to reach the ground, its h, that is height from the ground, that can be taken as 0 because it is about to reach the ground. So its height from the ground can be taken as 0. And its velocity will be the highest here. So let that velocity be v. So, when the object is about to reach the ground, its potential energy becomes 0. Okay, its potential energy becomes 0 because its height becomes 0. Alright, and kinetic energy becomes maximum. That is kinetic energy Ek is equal to half into mv square. Kinetic energy becomes maximum here. Okay, that is kinetic energy becomes the largest. So, what about its total mechanical energy here in position 3? Total mechanical energy E is equal to kinetic energy plus potential energy. So, here potential energy equal to 0. Kinetic energy is half mv square. Okay, so we got the total mechanical energy of the body when that body or object is here as half mv square. Okay, so you see, initially the object had only potential energy. Its kinetic energy was 0. When it is falling down, its potential energy decreases and kinetic energy increases. That is potential energy, sum of its potential energy converts into its kinetic energy. When it reaches here in position 3, its potential energy actually becomes 0. Potential energy becomes the least and kinetic energy becomes the largest. Okay, so a form of energy has been converted into another form of energy, because potential energy has been converted into kinetic energy here. Okay, but according to the law of conservation of energy, its total energy remains a constant. That is, the sum of the potential energy and kinetic energy of the object would be the same at all points. That is, the sum of its kinetic energy and potential energy remains a constant. So, we can write mgh, okay, potential energy, then kinetic energy half mv square. This remains a constant. Okay, that is the sum of kinetic energy and potential energy of an object is called as what? Its total mechanical energy. So, its total mechanical energy remains a constant. See, let the potential energy of the object when it is here as 60 joule. Okay, and kinetic energy equal to 0. That is, the object is at a particular height above the ground and it is at rest. That is why its kinetic energy is 0. It possesses some potential energy that is actually equal to 60 joule here. Okay, so what about its total mechanical energy? Total mechanical energy is equal to kinetic energy plus potential energy, that is 0 plus 60 joule. That is 0 plus 60 joule is equal to what? 60 joule. Okay, now when this object, it is falling down, okay, it is falling down, it is freely falling. So after some time it will reach somewhere here. So when it reaches here, it will have both kinetic energy and potential energy because this object is still at a particular height above the ground. So it has some potential energy and it is freely falling down. It is falling down now, so it is moving with some velocity. So it has some kinetic energy too. So when the object reaches here, it will have both kinetic energy and potential energy. Right. Let its potential energy be 40 joule. Okay, its height from the ground, initially its height from the ground was this much. Now its height from the ground is only this much. Okay, so its height from the ground actually decreased. So potential energy decreased from 60 joule to 40 joule. Okay, what is that? Decrease in potential energy. Its potential energy was 60 joule. It has decreased from 60 joule to 40 joule. So, decrease in potential energy is what? 60 joule minus 40 joule, which is equal to 20 joule. Okay, what will be its kinetic energy at this point? Its kinetic energy would be 20 joule now. Then only 40 plus 20 will give us 60 joule because total mechanical energy should remain a constant. Okay, so here if potential energy is equal to 40 joule, then kinetic energy would be 20 joule. Okay, because its total mechanical energy remains a constant as per the law of conservation of mechanical energy. So you see, during the free fall of the object, when it reaches here, there is a decrease of 20 joule in its potential energy. Okay, decrease in potential energy is 20 joule. So you see, its kinetic energy is actually increased, no, because its kinetic energy was 0. When it reaches here, its kinetic energy is 20 joule. That is, this object's kinetic energy has increased from 0 joule to 20 joule. So what is that increase in kinetic energy here? Increase in kinetic energy is equal to 20 joule minus 0 joule. Okay, 20 joule minus 0 joule, which is equal to 20 joule. Okay, so the decrease in potential energy at this point, when the object reaches this point, its decrease in potential energy is 20 joule and its increase in kinetic energy is 20 joule. Okay, that is, there is an equal amount of increase in its kinetic energy. Okay, that is, during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. See the effect of air resistance, because air is present here, the effect of air resistance on the motion is ignored here. Okay. So in this video, we have discussed about law of conservation of energy. That is, according to the law of conservation of energy, energy can neither be created nor be destroyed. It can only be converted from one form to another form. I hope you understood this. Thank you.